Hello, today I'm going to be talking about pKa, Ka, and acid strength. In under half a minute, here is a summary of this video. First, I'm going to be talking about the acid-base reaction. Then I'm going to be going over Ka and pKa and how to convert between them. Then I'm going to be going through the Ka and pKa in relation to acid strength. And then we're going to go over some examples. And finally, I will provide you with a practice problem so that you can check your progress in your understanding of this topic. If you're new here, my name is Liah, and on my channel you can find science and math videos. Here we have an acid-base reaction. Here we have the acid, the base, the conjugate base, and the conjugate acid. Now notice this involves a proton transfer, the proton being H+. The acid is going to donate an H+ ion and become the conjugate base, and then the base is going to gain that proton and become the conjugate acid of H3O+. Now what is Ka and how is it calculated? Well, Ka is said to be the acidity constant, and this is just how much that acid is going to break up into ions in the solution, okay, how much it's going to dissociate. And we can calculate it as follows. Ka is equal to the concentration of the products, right? So that includes the conjugate and the conjugate acid. These brackets just mean concentration of. And this is going to be divided by the concentration of the acid. So this is how Ka is calculated. A higher Ka value means that your acid is dissociating more than if the Ka is lower. Now, what is pKa? Well, this is the negative log of the Ka. Alright, so what you're going to do to find pKa is just multiply the Ka by negative log. So for example, if we had a Ka value of 7.2 times 10 to the negative 4, our Ka value would be the negative log of that Ka value. So 7.2 times 10 to the negative 4, and we would get 3.14 for our pKa value. As you can see, pKa values are larger than Ka values, and so this provides a convenient way in order to know the amount that the acid is dissociating. A large pKa value will mean that your acid is not dissociating as much as it would be if the pKa was lower. So let's expand on that idea. So starting with Ka, if we have high Ka values, as Ka goes up, the acid strength also goes up. Okay, so higher Ka values mean more acid strength. Now let's talk about pKa. So pKa, as this goes up, the acid strength will decrease. Okay, so this one has the inverse relationship. Okay, so higher pKa values mean that you have lower acid strength. Okay, you have a weaker acid. And as pKa goes down, then the acid strength goes up. Now let's go through some examples. We're going to compare nitrous acid with citric acid. And we are given the Ka values. Nitrous acid has a Ka of 4 times 10 to the negative 4, and citric acid has a Ka value of 1.8 times 10 to the negative 5. So which one do you think is the stronger acid? Nitrous acid or citric acid? So remember our trend. As Ka values go up, our acid strength also goes up. And so we know that the acid with the higher Ka value will be our stronger acid. Nitrous acid has a higher value than does citric acid for its Ka value, because a negative 4 exponent is a greater value than a negative 5 exponent. These values are written in scientific notation, so if you wanted to write this out, well, we would have this for the nitrous acid, so 0.0004, and for the citric acid we would have a value of 0.000018. So clearly this number is larger, and therefore nitrous acid is the stronger acid in this case. Now we're going to compare carbonic acid with lactic acid. Which one is the stronger acid? Try to find it on your own. So as we said, the trend for pKa and acid strength is as pKa values go up, acid strength goes down. So to find the stronger acid, we need to find which one has the lower pKa value. So we could draw our arrows like this. Lower pKa is higher acid strength. So let's compare 6.37 with 3.86. Which one is smaller? Well, clearly 3.86 is the smaller value, and therefore lactic acid is a stronger acid than is carbonic acid. So given pKa values, you would want the smallest value if you're trying to find the strongest acid. Now we're going to compare chlorous acid with water. Which one is the stronger acid? Well, we're given a Ka value, and we're also given a pKa value. Well, we can't compare these right away. We need to either convert this value to pKa or this value to Ka. So let's convert Ka to pKa. Now remember how we calculate pKa. That's going to be the negative log of the Ka value. And so the negative log of 1.1 times 10 to the negative 2. This is 1.96 and is a pKa value. So looking at pKa's, to find the stronger acid, we need the lower pKa value. And so we're going to compare these two. And clearly, this one is the lower pKa, which is the stronger acid. Alright, so then we can say that chlorous acid is a stronger acid than is water. Now it's time to test your understanding with this topic. Question 1 says, as pKa increases, acid strength will blank. And question 2 wants you to find the stronger acid between acid 1 and acid 2. Thank you so much for watching this video. I'll see you next time.